The Earth is 4.54 billion years old, plus or minus 50 million years. That's a lot of birthdays. In that time, Earth has undergone some pretty incredible changes. In a recent episode, we covered 4.2 billion years of that history, which saw the Earth transform from a molten ball of lava to a pale orange wasteland to a giant snowball to a flourishing tropical world. But Earth Saga is like a TV drama that keeps taking twists and turns, with some of the most incredible stuff happening in the last 300 million years. So, for those of you that were disappointed we didn't cover dinosaurs in part 1, well, you might want to stick around. And for anyone just tuning in, here's our premise. Imagine that alien scientists visited Earth at various stages in its development. What kind of planet would they find? I'm Alex McColgan and you're listening to the Astrum podcast. Join me today as we continue Earth Saga and imagine how the planet might have looked in its ancient past. But before we dive into any of that, here's something that not only helps me sleep, but also helps support the channel. Manta sleep masks are designed to create a blackout effect, making sure you receive the best sleep possible. They come in a range of different variants, from their original sleep mask to their Pro for comfort and breathability. However, if you love listening to these podcasts, there's also a sound version which will help you fall straight to sleep. Use my link in the description and the code Astrum at checkout to receive 10% off your next order. First, a reminder. To answer these questions, we'll draw on models that not all scientists agree on, although the job gets easier when our timeline is in the millions rather than billions of years. Not all of the science is settled, and some of these models are still being debated, but to the best of our current knowledge, this is what our planet could have been like. Now, back to the story. Our intrepid alien scientists are fresh off their exciting trip to Earth during the Devonian period, and are pretty excited about the direction things are headed. Obviously, they need to see what happens next. So they make a return trip 280 million years ago. Earth is now in its early Permian period. The biggest geographical change is that the continents of Euramerica and Gondwana have combined into a single landmass called Pangaea. The collision of these continents, called the Variscan orogeny, unleashes powerful tectonic forces that create a mountain range called the Central Pangaean Mountains. How tall are they? Well, Mount Everest is in the right ballpark, as this range is comparable in size to the modern Himalayas. In fact, they are so tall that they have a profound effect on the climate of Pangaea. The Central Pangaean Mountains lie just beneath the equatorial rainy belt, and our scientists quickly discover the impact of these giant mountains on the entire continent. South of the range, it is a mega monsoon climate. However, there is a flip side to all this rain. The mountain range in turn casts a rain shadow to the north, which creates a huge desert in Pangaea's interior. Basically, when air travels over tall mountains, it moves upward and cools, causing precipitation, so that by the time it crosses the mountains, the air is pretty arid. We see this effect today in the Gobi Desert, which is located in the rain shadow of the Himalayas. Pangaea's formation is a great example of how plate tectonics not only impact the world's land masses and oceans, but its weather as well. Yet, there are also other factors shaking up the world's climate. During the early Permian, the Earth is still in the latter days of an ice age dating back tens of millions of years, an event known as the Late Paleozoic Ice House. Our leading theory for this cooling is that the explosion of plant life during the Carboniferous raised Earth's oxygen levels and diminished its CO2, leading to a reduction in the greenhouse effect, with Milankovitch cycles also likely playing a role. During the Late Paleozoic Ice House, vast glaciers built up at the poles and in the higher elevations. Yet, by the early Permian, the planet has begun entering a warming trend. The polar ice caps are retreating, but glaciers remain in most of the high elevation mountain ranges. So, between the climate disruptions caused by Pangaea and the cooler than normal but warming global temperatures, life forms on Earth have had a lot of adjustments to make. Since our aliens last visited, the formation of Pangaea has produced a vast superocean called the Panthalassic, or Universal Sea, as well as a smaller ocean called the Paleotethys. The Panthalassic is so big it occupies almost 70% of Earth's surface. To gather more information, and, if possible, see what's down there with their own eyes, our aliens enter a submersible and dive in. As it turns out, the safety provided by said vehicle is much needed. While harmless trilobites and nautili remain in abundance, Earth's oceans have had some terrifying new inhabitants. Among them is one of the strangest predators ever to patrol the watery depths, Helicoprion, an 8-meter-long shark-like fish with a wall of teeth in its lower jaw resembling a buzzsaw. Most likely this wall is an adaptation for tearing apart and sucking soft-bodied prey. Our aliens have seen some strange creatures during their interstellar travels, but this is definitely one of the strangest. And honestly, Helicoprion would look utterly alien to us too. I personally have always dreamed of a day when humans discover extraterrestrial life, but until that day comes, our best resource for understanding how life can evolve under various conditions is Earth's own fossil record. Earth was a different planet back then. In our own solar system, moons such as Europa, Ganymede, and Enceladus may have subsurface oceans suitable for strange life forms. Meanwhile, on land, insects have begun to flex some serious muscle. There are all sorts of beetles, including Permocupidae, a wood-eating beetle, and Meganissoptera, an extinct order of giant dragonflies. Just imagine a dragonfly with a wingspan about the size of common seagulls and you'll have the idea. Another frankly bizarre newcomer is Diplocaulus, an early amphibian with a boomerang-shaped head. But by far, the most interesting quadruped of the early Permian is the Dimetrodon, a 2 to 5 meter long lizard-like organism with a massive frill running along its back like a sail. Although it is often mistaken for a dinosaur in the popular imagination, this 2 to 4 meter sail-backed predator is actually a synapsid, more closely related to modern mammals than reptiles. Believe it or not, the sail could be an adaptation that predates the transition from exotherms, or animals that absorb heat from their environment, to endotherms, which regulate temperature internally. You know, warm-blooded creatures like you and me. Dimetrodon's sail contains a network of blood vessels, which allows it to raise its temperature more quickly in sunlight, an early step towards temperature regulation. On a planet experiencing all kinds of climatic changes, this ability to regulate temperature would certainly be advantageous. It's a wonderful illustration of how much living organisms can and must change in order to survive. Our planet's climate is like a complex system full of inputs with a biosphere as corresponding outputs. Planets like ours dictate what sort of life can exist on them. And interestingly, as a planet changes over time, the type of life it can support also changes. Impressed by Earth's development, our alien scientists decide to return in another 100 million years. Unbeknownst to them, they will miss the largest extinction event in Earth's history. And I'm not talking about the asteroid that eventually killed off the dinosaurs. A much more catastrophic extinction takes place around 252 million years ago, called the Permian-Triassic Extinction Event. Our leading theory is that volcanic eruptions release a huge amount of CO2 into the atmosphere, which raise global temperatures and make the oceans more acidic. This catastrophic event eradicates about 70% of terrestrial vertebrate species and 80% of all marine species, a mass die-off unmatched by any other in the history of the planet. Yet, as devastating as this is in the short term, it would eventually clear the field for a whole lot of evolutionary diversification during the Triassic and Jurassic. And chief among the beneficiaries is a group of reptiles that would one day rule the planet: dinosaurs. Our alien scientists returned to Earth during the late Jurassic period, 150 million years ago. Although Pangaea managed to hang around until the early Jurassic, by now it is starting to drift apart due to tectonic movements in the planet's lithosphere. The Earth is made up of about 15 to 20 tectonic plates, which are always moving toward or away from each other at a rate of around 1.5 centimeters a year, which, interestingly enough, is pretty much the same rate as our toenails grow. As plates move away from each other, they open a rift marked by outpouring basaltic lava. So, beginning around 200 million years ago, Laurasia breaks away from Gondwana, creating two smaller supercontinents. In the north, Laurasia contains modern-day North America and Eurasia. To the south, Gondwana includes modern-day South America, Africa, Australia, India, and Antarctica. A narrow body of water called the Tethys Sea is also opening up. It will one day grow into the North Atlantic Ocean as outpouring basaltic lavas at the Mid-Atlantic Ridge continue to push the landmasses farther apart. Meanwhile, in the south, Antarctica and Madagascar have begun to separate from Africa, opening up the Proto-Indian Ocean. While the continental landmasses still look quite different from how they look today, our alien visitors already have an inkling of where Earth's continental configuration is heading. The climate of the period is scorching hot. Global temperatures are 5 to 10 degrees warmer than they are today, with atmospheric CO2 levels approximately 4 times greater. What contributed to all this CO2? Very likely, the mass extinction of plants during both the Permian-Triassic extinction event and a subsequent die-off called the End-Triassic extinction played hefty roles. Global temperatures are so warm that ice sheets are unable to form at the poles. Instead, the poles are covered in forests, which likely experience warm summers and cool, snowy winters. With so little water locked up in glacial ice, sea levels are significantly higher than they are today, with the peak happening right around this time, about 140 meters higher. In terms of flora, gymnosperms such as conifers have become one of the most successful plant types. Some trees, like the extinct Araucaria mirabilis, look eerily similar to what you might find today. Their seeds bear more than a passing resemblance to ordinary pine cones. This is also a golden age for cycads, palm-like vegetation with woody cylindrical trunks and stiff pinnate leaves. These plants grow heartily in the late Jurassic's expansive tropical and subtropical climate zones. As our alien scientists step out of their ship, they hear an ominous rumbling. Looking over, they spot a pack of towering sauropods, with necks stretching about 3 times higher into the sky than any modern-day giraffe. Not just any sauropods either, Supersaurus, one of the most massive terrestrial animals in Earth's history, measuring up to 35 meters long and weighing 40 metric tons. Getting over their initial fright, our alien visitors realize that these Goliaths are in fact herbivorous grazers, well adapted for reaching high vegetation. But their relief is short-lived. Stalking some of the smaller sauropods is a rangy Allosaurus, a formidable species of carnivore nearly 10 meters long with dozens of needle-sharp serrated teeth. Luckily, our alien visitors escape their brush with the hungry carnosaur and decide to finish the rest of their tour from the safety of their ship. Once they're in the air, they encounter a feathered Archaeopteryx, an avian dinosaur considered to be one of the first birds. Archaeopteryx is also sharing the skies with large flocks of non-avian pterosaurs, such as Dimorphodon and the crested Pterodactylus. These winged predators are well adapted for catching smaller animals and invertebrates in their toothy, beak-like jaws. But as our alien scientists stop their expedition for lunch in one of the more sheltered forest glades, it's something small and unassuming emerging from a burrow that catches the xenozoologist's interest again. A small furry creature called Taeniolabis. Taeniolabis and other members of the extinct order Multituberculates, named after their unusual teeth, which they'd used to chew in a forward and back grinding motion, are some of the earliest mammals. And while they may look unassuming, our aliens quickly realize there's something different about them as they observe their sociability and the way that they play with one another. These little rodent-like creatures have highly developed brains, especially compared to pea-brain dinosaurs, and they are warm-blooded with a useful adaptation called fur to keep them insulated. Little do our alien visitors know, the great descendants of these humble, scurrying creatures will one day outlive the dinosaurs and dominate the Earth. But that chapter will have to wait for a return trip by our intrepid travelers. They are worn out from the scrapes and scares of this trip, but they certainly have an idea of Earth's immense diversity and adaptability. Who knows? They may come back to finish the story another day. I hope you enjoyed this second chapter on Earth's planetary evolution. If you like what you've heard, please feel free to follow us for more podcasts on other fascinating space topics. But for now, I'm Alex McColgan, and this has been Astrum. All the best, and see you next time.
you.